All right, let's take a look at 47. You've got to recognize what you have. What you have is h of x equals the sine of u times the cosine of u. Okay? And u is 2x. We got to product rule this. So that'd be the first function, so to take the derivative. So h prime of x equals the first function, the sine of 2x, times the derivative of the second function. Well, to take the derivative of the cosine of 2x, that's the cosine of u, so that's negative sine of u times the derivative of u. So negative sine of 2x times the derivative of 2x. Then we put down our big fat plus sign, and we do the second half of the product rule. So the second half will be the second function, the cosine of 2x, times the derivative of the first. So to take the derivative of the sine of 2x, the derivative of the sine of u is cosine of u times the derivative of u. So that'll be the cosine of 2x times the derivative of 2x. And then let's simplify a little bit. In front of the plus sign, we have a negative 1 as a coefficient and a 2. So multiply those together. Then multiply sine times sine. So we get negative 2 sine squared of 2x. Behind the plus sign, there's no negative. So it's 2. And then cosine times cosine, cosine squared of 2x. Does that help for 47? Yeah. Yeah, they then used another trig identity to go further. I'm really happy if you get this far. I'll be really happy if you get this.
All right, sure.
All right, which one's next?
To number 37. Wait, no, 31.
31. All right, 31 is one of these awesome problems where we start with the chain rule, and inside of the chain rule, I'm going to use the quotient rule. Now, some of you seem to try to avoid the quotient rule at nearly all costs. Sometimes I rewrite things too. I do. You've seen me, right? But there's nothing wrong with the quotient rule. One of the nice things about the quotient rule is once you've done the quotient rule, it's not as hard to simplify as a lot of them are where you have to factor out quantities with negative exponents and all that stuff. I think that's kind of complicated. But the quotient rule, not so bad. So f of v equals 1 minus 2v divided by 1 plus v, all of that cubed. So it's u to the third. That's what our function is. So we use the general power rule on it. So if we're trying to find the derivative of u to the n, that's going to be n times u to the n minus 1 times the derivative of u. And remember why this works? Because that's the dy du. Okay? So, exponent times coefficient, 3, u, so that entire quantity, 1 minus 2v divided by 1 plus v, to the n minus 1. 3 minus 1 is 2. So, this, what I just circled, is what I have circled over here. Now we've got to do times the derivative of u. So times, and then I need to use the quotient rule to find the derivative of u. So quotient rule says the derivative of that will be the bottom, 1 plus v, times the derivative of the top. The derivative of 1 is 0. The derivative of negative 2v is negative 2. Minus the top quantity, because if I don't put a parentheses around that, I'll mess up the negative, right? So minus parentheses 1 minus 2v times the derivative of the bottom. Well, the derivative of 1 is 0, but the derivative of v is 1. Now I didn't write in times 1, but it's there, isn't it? Times 1 divided by the bottom, 1 plus v squared. So, questions on that first step? All right, so let's start simplifying. One thing I'm going to do is this. This quantity here with an exponent of 2, I'm going to make that the numerator squared over the denominator squared. And the reason I want to do that is that way I can multiply my numerators together and I can multiply my denominators together after I've done that. So that was my first step of simplifying. Okay? And then I'm going to leave that 3 as a 3. Notice for the time being at least, I'm going to leave that 1 minus 2v quantity squared as 1 minus 2v quantity squared. But over here, I'm going to start multiplying that out. So let's see, distribute the negative 2, get a negative 2 minus 2v. Distribute the negative 1, get a negative 1 plus 2v. Combine the like terms, that just turns into a times negative 3, which makes me feel a little bit like a genius that I didn't go ahead and multiply that out. Might as well leave it factored because all that came down to not be a nice little constant. This is going to actually look kind of nice when we're done. So, I'm down to here. Well, 3 times negative 3 gives me a negative 9. Then I'm just going to leave that quantity squared. And in the denominator, I had this quantity squared times the same quantity squared, so it's that quantity to the 4th. I kind of like the way that one simplified. Questions on 31? All right, what do you want to see next? 92. All right, on 92, let's see. The directions say the graph of a function f and its derivative f prime are shown. We have to figure out which one's f and which one is f prime. All right, so you can see what I've got labeled. All right, all we started with was this, 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 and this. And here's what I started thinking, all right? Sure looks like these two pieces have to go together since they have the same domain. All right, so let's see what's going on. If this one was f, it's decreasing. When a function is decreasing, what's the sign of its derivative, positive or negative? Negative. Well, that can't be then, can it? The red one can't be the f because if the black one is f prime, it should be negative. I'll try reversing them. Let the black one be f. It's decreasing. If it's decreasing, its derivative is always negative. That works. Black one f, red one f prime. Then over here, let's do the same kind of thing. Let's say, well, maybe that one's the f. But what's it doing? Decreasing. So what would its derivative have to be? Have to be negative. So that doesn't work. Does it work if the black one is f? Look what the black one's doing. It's increasing. If it's increasing, what sign is its derivative? Positive, and the red one is always positive. So it works for the black one to be f and the red one to be f prime. So there's no big trick to this other than pick one of them to be f, see if the other one makes sense as f prime. If it doesn't, reverse them, see if that makes sense. One of them will, right? Okay, what else? 83. All right, on 83, the directions tell us to find the second derivative of the function. All right, on 83 then, there's f of x. Now, here's where I think sometimes I've confused you, and I didn't mean to. I'm actually going to use two rules on this one. I'm going to use the constant multiple rule and the general power rule. When we have something like that, its derivative looks like that, right? So what I think I've done that to accidentally confuse some of you is I will be using that constant multiple rule. It's going to be 2 times whatever the derivative of the rest of it is, right? Constant multiple rule. So I've been saying exponent times coefficient because it's the constant multiple rule, and that's what's going to happen. I'm going to have 2 times, well then that exponent of 3 becomes a coefficient of 3. 2 times 3 is 6. I've been doing that in one step. Unfortunately, leading some of you to believe that no matter what that coefficient is, well, here's the mistake. Coefficients are constants, all right? If that was a 2x, then I couldn't do it this way. I'd have to use the product rule, okay? Because coefficients are constants. Once there's an x in there, I can't just use the constant multiple rule anymore because it's not a constant. Am I making any sense? So I think what's happened is some of you thought, oh, I can multiply that 3 times that 2x, make that a 6x, finish off the chain rule, and I keep saying, no, it's a product rule, and you keep not seeing why it's a product rule. It's because coefficients are constants. If that's anything besides just a constant, I've got to use the product rule on it. It'd be the first function times the second function situation. Does that make any sense? Okay. So 3 times 2, 6, u, x squared minus 1, to the n minus 1, 3 minus 1 is 2, times the derivative of u. The derivative of x squared minus 1 is 2x. And again, beating a dead horse, that's the dy du from the first version of our chain rule. Okay? Then let's simplify that just a bit. I can multiply the 6 times the 2x and make that a 12x. Then I still have that quantity squared. So now when I take the second derivative, I can't do it the same way I did the first derivative, can I? Because that's not a constant. I have to treat that as the first function, that quantity squared as the second function. So I have to product rule this one. So that'll be the first function, 12x, times the derivative of the second function. And to take the derivative of that quantity squared, I must use the chain rule. The general power rule is the version I'm going to use. So that'll be exponent times a coefficient of 1. Okay? So 2 times 1 is 2. U to the n minus 1, 2 minus 1 is 1, times the derivative of u. The derivative of x squared is 2x. So that's the first function, 12x, times the derivative of the second. And I found the derivative of the second using the chain rule. Plus the second function, the quantity squared, times the derivative of the first. And the derivative of 12x is just 12. So does that second derivative make sense? Okay. Then we've got a lot of, let's see, 12x times 2 times 2x is 48x squared, then your quantity. And there's nothing to do behind the plus sign besides put the 12 in front. All right, and then what can I factor out of the from what's in front of the plus sign and from what's behind the plus sign? Well, 12, right? 12 goes into 12, 12 goes into 48. Greatest common factor of 12. Then I've got an x squared minus 1 as well. So x squared minus 1, and always use the smaller exponent. So use the exponent of 1. Now what am I left with? Well, what's 48 divided by 12? 4. What's x squared divided by not anything else to divide it by? X squared. What's that quantity divided by itself? 1. So no need to put a times 1 there, is there? But everybody see how I got the 4x squared? Plus, what's 12 divided by 12? 1. Don't need to put a times 1 there, is there? And then what's that quantity divided by the same quantity with an exponent of 1 instead of 2? When you divide factors with the same base, you subtract the exponents. So 2 minus 1 is 1. You with me on the factoring step? Yeah. Yes, no, maybe. Then all I got to do now is simplify inside that last parentheses. 4x squared plus x squared is 5x squared. And don't forget the minus 1. All right, we through with 83? All right, 85, same thing, find the second derivative. Yeah. All right, so we've got the sine of x squared. Now, that does not mean sine squared of x, does it? So u equals x squared. So the first derivative, the derivative of the sine of u, is the cosine of u times the derivative of u. So it'll be the cosine of x squared times the derivative of x squared. You with me there, Alex? All right, remind me when I'm done. The only thing I'm going to do to that, to simplify, is put the 2x in front. And I know you can see it there, but when you see 2x times the cosine of x squared, and you know you're supposed to take the derivative, what rule do you see? I know you see what I did, but what rule do you see when you see 2x times the cosine of x squared? Product rule. That's the first one, isn't it? I've got to do that as the first function, that as the second function. So it's product rule. So f double prime of x will equal the first function, 2x, times the derivative of the second. Now, when you're taking the derivative of the second, what rule do you see? Chain rule. So the derivative of the cosine of x squared will be negative, well, derivative of cosine of u is negative sine u times the derivative of u. So the derivative of cosine of x squared will be negative sine of x squared times the derivative of x squared. So negative sine of x squared times the derivative of x squared. So what I have underlined in blue there is the first function times the derivative of the second. Plus the second function, the cosine of x squared, times the derivative of the first. And what's the derivative of 2x? 2. And then simplify 2x times a negative times a 2x will be a negative 4x squared times the sine of x squared. And then put the 2 in front of the cosine to put plus 2 cosine of x squared. Does that help for 85? Now, the trig ones are giving us some trouble. That's not unusual. But here's what you need to realize about the trig ones. Do they involve any trigonometry?
Not really.
They don't. They're a really good example for me to see and for you to test yourself to see whether or not you actually understand the rules you're trying to apply. Because there's not any trigonometry involved in number 85. It's, can I apply the rules I've been shown? Okay? Which isn't always all that easy. All right, Alex, which one did you want? 48. All right. So when we see this, what's the rule that you see when you know you have to take the derivative of that? Product rule. The secant of 1/2 theta is your first function. The tangent of 1/2 theta is your second function. Okay? So here we go. Product rule says that g prime of theta will equal the first function, the secant of 1/2 theta, times the derivative of the second function. Now, that's the tangent of 1/2 theta, that's our tangent of u, isn't it? Right? It's not just an x. If the 1/2 wasn't there, we could just treat it like an x, but it's not. It's a 1/2 theta. So u is 1/2 theta. So tell me, do you know what the derivative of the tangent of u is? Look it up. It's on page 135. What's the derivative of the tangent of u? Secant squared of u times u prime. So secant squared of 1/2 theta times the derivative of 1/2 theta. You have to, because that's your u. All right, plus the second function, the tangent of 1/2 theta, times the derivative of the first. Now, that first function is the secant of u, where u is again 1/2 theta. So tell me, what's the derivative of the secant of u? It's on page 135. Secant of u, tangent of u, times derivative of u, right? Secant of u, tangent of u, times the derivative of u. All right, y'all got to have those memorized for the quiz tomorrow. And then some housekeeping. All right, in front of the plus sign, how many factors of secant 1/2 theta do I have? Nope, not one. 3, don't I? 1 here, 2 here. So I've got 3 of them, so that's a secant cubed 1/2 theta. Then I might as well put the 1/2 in front of that as coefficient. All right, behind the plus sign, how many factors of secant do I have? Just 1. How many factors of tangent do I have? 2, so tangent squared 1/2 theta. And then I've got this left over here 1/2, so put that as a coefficient. All right. Now, notice that in front of the plus sign, I have a factor of 1/2, and I have a factor of secant of 1/2 theta. Behind the plus sign, I have a factor of 1/2, and I have a factor of secant of 1/2 theta. So I can factor out a 1/2, I can factor out a secant of 1/2 theta. Now, one of them has a cubed on it, the other one doesn't. Always use the smallest exponent. So use the exponent of 1. Now, what am I left with? Well, in front of the plus sign, 1/2 divided by 1/2 is a 1. And then secant cubed divided by secant will be secant squared. 1/2 theta. Behind the plus sign, 1/2 divided by 1/2 is 1. Secant 1/2 theta divided by secant 1/2 theta is another times 1. And then there's nothing to divide the tangent squared 1/2 theta by besides a 1. So I get tangent squared 1/2 theta. And maybe there's a trig identity that goes with that. I don't remember my trig identities. So there we go. All right, we got time for one more. 99. All right, on 99, let's see. It says the graphs of f and g are shown. Let h of x equal f of g of x and s of x equal g of f of x. Find each derivative if it exists. If the derivative does not exist, explain why. For number 99, we're supposed to find h prime of 1 and s prime of 5. So before I can find h prime of 1, I need to find h prime. So they gave me that h of x is f of g of x. So use the chain rule to find h prime of x. All right? Remember that one of our versions, if we had h, well, it's actually h of x, to equal f of u, where u equals g of x, it was h prime of x equals f prime of u times the derivative of u. So that would be f prime of g of x times the derivative of g of x. That's the same thing as dy du times du dx. Those are the same. Those are the same. So, like I said early on, sometimes one notation has an advantage over another. This one has the advantage right now. Okay? So, f prime of u times the derivative of u. F prime of g of x times the derivative of g of x. Well, now we can find h prime of 1. All right? So, replace all the x's with 1. Make that h prime of 1 equals f prime of g of 1 times g prime of 1. We need to figure out what g of 1 equals. So we have to look at the graph on page 139. When x equals 1, what does g equal? It equals 4. I got that from the graph, not from what's on the screen. From the graph on page 139, when x equals 1, y equals 4 on the graph of g. So I replace g of 1 with 4. Now, what's g prime of 1? Looking back at the graph, g is linear at x equals 1, so I can just find the slope of that line, and that'll be what g prime equals. And the slope of that line is a negative 1/2. So I got that because g looks like that when x equals 1, and then I counted spaces. The slope of that was negative 1/2, so that's what the derivative is when x equals 1, negative 1/2. Now, f prime of 4. Now I've got to look at the graph of f when x equals 4, and f looks like that when x equals 4. Count the spaces. Turns out the slope of f when x equals 4 is negative 1. So negative 1 times negative 1/2 is positive 1/2. You with me on part A? Okay, some of you aren't because you weren't looking back at your graph like you needed to understand what was going on. All right, part B. S of x equals g of f of x. S prime of x then will equal, well, it's the chain rule again. F prime of u is now, since g is our outer function, it'll be g prime of u times the derivative of u. Well, since u is f of x this time, the derivative of u is f prime of x. Now we need that because we're supposed to find s prime of 5. Like we did before, we replace all the x's with 5s. All right. Now, f of 5. So we look at the graph. When x equals 5, the value of f is 6. So f of 5 becomes 6. F prime of 5. That'll be the slope of f when x equals 5. And the slope of f when x equals 5 is negative 1. With me? All right, g prime of 6. What happens to g when x equals 6? It's doing that, isn't it? Remember the old left-hand, right-hand thing? The slope from the left would be 0. The slope from the right would be negative 1, maybe, negative 1/2, whatever it is. They're not the same, so there's no derivative there. Remember also our rule that there's no derivative at a cusp. That's a cusp. So g prime of 6 does not exist. Well, if g prime of 6 doesn't exist, and you multiply it by negative 1, that doesn't exist either. So s prime of 5 is undefined. I guess you could put negative does not exist. All right, we'll stop there.